My name is Gierad Laput, and I'm a first-year PhD student at Carnegie Mellon University. My advisor is Chris Harrison. This work was done in collaboration with my lab mate, Robert Chow. We are in the Future Interfaces group at CMU's Human-Computer Interaction Institute. The wristwatch has received continuous technical refinement since its early inception in the 1900s. The smartwatch is an exciting vision, and today we can finally do them. Products like the Pebble smartwatch have been popularized in the public, and multiple manufacturers have recently released their own smartwatch devices. However, these devices have tiny screens and they rely on tiny buttons and touchscreens for input. The problem is particularly acute because relative to the display, our fingers are large. This is a hard problem, and people have been thinking about different solutions. There's work which focuses on broad ways to interact or type in tiny screens. Researchers have also looked at the general idea of applying force on a screen, such as sheer touch or pressure sensing. Also, using the watch band or incorporating capacitive bezels is another technique that has been considered. And finally, researchers have examined using in-air gestures or any form of proximity or magnetic sensing to utilize the area around the watch. All of these are really cool, but what we propose is a new input approach to smartwatches, where we use the watch face for physical manipulation. We use mechanical sensors to digitize physical movements on the watch face. What's neat is that having multiple mechanical sensors allows us to increase the input bandwidth. This new input approach allows us to use the watch face as a multi-degree of freedom mechanical interface. This allows us to pan in multiple directions, twist both clockwise and counterclockwise, tilt right and left, and then press the watch face down. This video shows raw data of our prototype. Users can pan in 2 dimensions, rotate clockwise or counterclockwise, tilt left, tilt right, click, click, and pan. Notice how the mechanical movements are rate controlled, which makes the gestures really smooth. Also note that our proposed interactions do not take anything away from the current smartwatch input techniques. And in fact, it is easy to imagine our technique working in parallel with current smartwatch input, such as touchscreens and buttons. To demonstrate the potential of this approach, we built applications that fell into 5 interaction modalities: pan and twist, twist and click, 4-way navigation, gestures, and gamepad input. Note that in the next few slides that I'm going to show you, the applications we demonstrate are difficult or even impossible to use with today's smartwatches. In this map application, users navigate by panning the watch face. Users can zoom in and out by twisting the watch face clockwise or counterclockwise. Also note that by pressing the watch face, users can get information on a specific map item. This is a clock application. When you press and twist, you set the alarm time. Depressing will allow you to configure the watch the alarm time to that specific command. You'll notice that throughout this process, we never occlude the screen. In this camera application, users can zoom in and out by twisting the watch face clockwise or counterclockwise. And they take a photo by clicking. In this calendar application, users can pan left and right to navigate between days of the week. To navigate items for a particular day, users can pan up and down. And then by pressing, the user can look at a specific calendar item. Similarly, the 4-way navigation technique extends to other applications. In this music application, users pan left and right to navigate. They can scroll up and down to look at different items in the menu. They can twist left and right to twist clockwise or counterclockwise to control the volume. And they can also click the watch face to pause or play music. you'll notice that when we scroll, it's actually rate controlled. Users can also control commands gesturally. Here you press the watch face down, gesture, and then release. And the system classifies the gesture. For example, a user can use the gesture V for voicemail or C for launching the calendar application. Using the watch face as a mechanical input allows the smartwatch to be used as a gamepad input. Here's a first-person shooter game. Notice that we can move forward and backward, and strafe left and right, and turn left and right, and fire, and we're not even using tilt left or tilt right. What you just saw are some examples that demonstrate the potential of our approach, some of which are difficult or even impossible to use in today's smartwatches. I want to very quickly talk about limitations. Like all approaches, there's pros and cons. First, we're saying that we're going back to moving parts, but devices today now use solid state. However, one possible solution is to use strain gauges, force-sensitive resistors, or other similar sensors. They measure the same mechanical movements we employ, but are more compact and require less moving parts. Second, we're manipulating the watch face and it could displace the visual content that the user is interacting with. This was a concern at first, but we learned from our users that this impact was minimal. And mainly because when users are manipulating the watch face, the user's visual and motor system work in tandem to cancel the effect. As with capacitive touch, buttons, and voice, there's potential for accidental input. Our technique has the potential to get snagged by clothing or incur accidental movement, or being pushed when the user's hands are laying on the table. However, an unlock mechanism is one way to prevent these types of accidental input. So in summary, we designed and implemented a new smartwatch interaction technique that uses the watch face as a multi-degree of freedom mechanical interface by allowing the user to pan, zoom, navigate, select, and perform actions using physical controls. Our approach is inexpensive and can work in parallel with existing input techniques such as touch and buttons and voice, and without taking any functionality away from these modalities. And now I open the floor for questions.